Hello, everyone. My name is Itamar Holder, and I'm a principal software engineer working for Red Hat. I'm a KubeVirt maintainer, and as always, it's great being here in Brno, such a great city and such a great conference. And I'm here to talk to you about the VEP Police, which is basically an AI agent which helps us maintain and govern the KubeVirt repo. So let's start. The first chapter, the chaos. So in the beginning, basically we didn't have any structured way to contribute big features to KubeVirt or complex behavior changes. And this led to all sorts of weird PRs that were like giant PRs, no comments, and it was very hard to understand what was going on. So just to give you an example, this is a PR, it's censored, of course, from a long time ago. And it basically, as you can see, changes 86 files. There's only one commit, and there are two conversation comments on the PR. One of them is this one, which just says LGTM approve, everything's fine, let's merge it. The other one was the PR description itself, right? So basically, and it wasn't too informative as well, as you can imagine. So I'm sure there was a conversation somewhere around this huge change, but it was just not public. And so somebody that came from the outside just didn't have any idea what was going on. And it's important to me to say that I'm not pointing any fingers here because it's sometimes important at the early life of a project to advance fast and to not have too much bureaucracy. But my point is that it was just a mess, right? It was messy, it was hard to understand what was going on, and there were three main problems because of that. So first of all, there was zero transparency. Somebody coming from the outside just doesn't know, what this design was chosen, which alternatives were considered, why it was implemented this way, what's the motivation for the change, and so on and so on, which basically made us very non-inclusive. So if we were coming from the outside, it was very hard to participate. And finally, there was no planning. So like, how do different features should take into account other features? Where do we see ourselves in a few years from now? What's the vision, right? This was basically non-existing. What we did have at the time is design proposals. And this was basically a one-shot document that tried to understand everything that I was just talking about, like what's the design, which alternatives were considered, and so on. But the problem with design proposals is that they were one-shot documents. So you would just write them, merge them, and forget about them. And a lot of times when you were starting to implement a feature, you would soon realize that that design was problematic and things, you didn't think about problems when you were designing it, and you need to change the design. But then the design document becomes outdated very quickly. And that's how you get to a situation where it just, it's just not relevant anymore. And we needed a solution for this. We needed to make the maintenance of the repo better. And by that time, I was working on a node swap feature for Kubernetes. This basically integrated being able to use swap memory into Kubernetes, and there's a talk I did at KubeCon about that topic if you're interested. But in the context of this talk, what I want to say is that it took me years, right? It was a very big change. It was hard to do for a lot of reasons. But this was great in a way because it got me to be very involved within the Kubernetes community and to understand how they govern their repo over there. And so it was I was exposed to the KEP process and how they do things. And I said to myself, like, we need to have something similar. We need to have a structured process that is clear, transparent, equal for everyone, so we can basically maintain the repo more easily. And so this was the beginning of the VEP process. So as you can see, VEP is very similar to KEP. It basically stands for Virtualization Enhancement Proposal. And it's very, very inspired from the Kubernetes process. It's not that I invented it. I basically took the Kubernetes concept and adapted it to our community and to our culture and to the fact that we are a much smaller community, of course. And basically, the idea of the process is that it had two core ideas. One of them is that it's now a live document. So whenever you, let's take the previous case. You design something, you merge the document, everything's great, then you go to implement it, and then you find out that the design needs to change. So now you have to go back to the document and update it. So it becomes a source of truth for what actually is happening like in the code. Another thing is that we introduced the graduation phases, meaning alpha, beta, and GA. Very generally speaking, alpha means no promises, anything can break, anything can blow up, no backward compatibility guarantees. Beta means it's on by default, it's almost ready to GA. And when it's GA, basically you don't need a feature gate anymore, and it's on, unconditionally. And I think this was a very important step in the right direction. So suddenly we had a structured way of contributing big features or changes to the community, and we were becoming much more transparent, and that led us to be much more inclusive. Now it's much easier for an outsider or a newbie to come from the outside and participate in KubeVirt. And I think that the testament that it really worked is that now there are a lot of big companies that were starting to participate in the repo. So for example, some notable examples are NVIDIA, which contributed DRA integration. I think we were one of the first big projects that integrated DRA from the very beginning, thanks to NVIDIA. We had Microsoft coming along and contributing the multi-hypervisor support, which is something we were talking about for years. And suddenly it's coming into life. We have companies like ARM and Intel and AMD working on confidential computing, and there are more examples to that. So I think it was a very important step. But this caused us a different problem, which is the growth explosion. So basically, it caused a new headache because suddenly more people were coming in, more features, we needed to maintain and review. And just to give you like a glance into it, in version 1.6 we had 8 tracked VEPs, and this is kind of manageable. And then in the next version, it came to 14, and then 21, and then now we have 41 VEPs in this cycle. So this is great for the project, but it's just a nightmare for maintainers. Like, how do you keep track of all of that? With 41 VEPs, and each VEP can have multiple PRs, right? So we're talking about, 100 PRs that keeps changing every day. How can you even understand what's going on? And we were chasing our own tails with just trying to understand like who needs our attention, who's blocked, what's the probability of a certain VEP to make it through the code freeze, did you fulfill your requirements, and so on and so on. And basically this was not scalable. The number of VEPs kept growing in a huge pace, and the number of maintainers stayed relatively the same. And we didn't want to go backwards. Right? We made such a good progress into the right direction, and now people were starting to feel that we became unresponsive and therefore non-inclusive again. So this is the main thing that we wanted to avoid to begin with. And this led us to the agent solution, which is basically the bulk of this talk. So we thought, let's build an AI agent. Back in the day, I didn't have much experience with AI or agents or anything like that. And after considering a few alternatives, I decided to just implement it completely from scratch, which means that I didn't want to rely on a certain technology like Cloud Code or something like that, but mainly want to use direct LLM calls with a framework, of course. And the main reason that I chose to do it this way is that I wanted first of all, not to rely on a too specific technology because things are changing so rapidly. But also, I wanted to tailor it for KubeVirt needs and to be highly customized for what we need, right? And also, it was a great way to experience with AI and understand how things work under the hood, which is another bonus. So eventually, I chose a framework that's called LangGraph. And LangGraph is a Python framework that basically it's a graph, it's a state machine, and every node basically executes something else. And you can execute a few nodes in parallel and stuff like that. And basically, it just makes things a bit more structured and easier. So the main components, the main idea of it, was that first there is like a central coordinator or scheduler that decides when the agent actually kicks in. Afterwards, it fetches all the VEPs. It filters out the ones that are not relevant for the current cycle. And then there is parallel monitoring. So there are parallel nodes, and each one of them tries to understand if the VEP, like what's the state of the VEP from a different aspect. So for example, when are the deadlines? Does it have a big probability of making it through the code freeze or the upcoming freeze? What's the activity? Was there a recent activity over there? Are there main blockers? Are the reviewers happy? What's the sentiment of the reviewers towards the change? And so on. These all are happening in parallel. Then they're all being merged into a huge list of realizations, let's say, which are being then passed into an LLM, which does a deep reasoning on all of the information. And tries to basically, as I said earlier, give us, try to let us know who needs our attention. That's basically the main goal here. Finally, it does notification and tracking by sending emails, Slack messages, but it also maintains a few columns in our GitHub project board. So we have a project board for every release. This is, by the way, the same thing that Kubernetes do, in which we have all the VEPs and their status and what's going on. So there are 4 columns in the table there that the agent maintains itself. And basically what it does, it tells us what's the probability of it surviving the code freeze, and it also adds a comment. So for example, there was no activity for 2 weeks with this VEP, so you should have a look. Or maybe something like, there's a blocker. This reviewer really didn't like what's going on there. And the architecture in its fullest looks like this. And this is a bit overwhelming, but basically you can find everything that I was talking about earlier. So there is the scheduler that calls the fetch VEPs node, coming back to the scheduler, and then it runs the monitoring in parallel, right? And check deadlines and activity and compliance and exceptions and whatever. Then it's being merged. Analyze combines basically is the deep reasoning part. And then there are a few nodes afterwards that I will talk about a bit later. And this is the URL for the repo, so you can, of course, have a look. And there are a few lessons learned from this process. So first of all, I learned a lot from it, really. It caused me to understand stuff much better because I just understood like how it's working under the hood. And in the same time, I was working on building my own setup with Cloud Code, for example. That's what I use mostly. And I felt it was like a yo-yo because like improving my local setup really helped me improve the agent and vice versa. So it was a very fruitful learning experience. But I did make some mistakes. Maybe some of them are a bit obvious. The first one is that I thought, OK, so AI is smart, right? It just knows everything. So all of the nodes that you saw there were completely LLM-based. Like I didn't write almost any code and basically relied on prompts and on LLM to just understand what they need to do. And I thought, that's fine. it will just know the right thing. And this was a very big mistake. And I think that there are three main problems that emerge from this approach. So first of all, it was extremely slow. It was extremely verbose, right? Another problem is that it was extremely inconsistent. So when you do things like that, every time the agent ran, because it's just a probabilistic tool in the end of the day, the output looked differently. And since we didn't have like a fixed format to work with, it's just impossible to parse, and it's also very ugly. So it's bad also for humans that try to look at it and understand the data, and for tools or scripts that try to parse it and understand what's going on. Another thing is that LLMs, which was surprising to me at first, sometimes they just don't listen to you. You tell them, please don't do this and that, and they do this and that. And you ask them, like, why did you do it? I just told you not to do it. And they say, I don't know. I'm just a probabilistic tool. Leave me alone. So it was very funny for me, but yeah, I mean, this is just a reality. So what I want to say here is that I started, eliminating LLM calls all over the place, and started to replacing them with actual code. And basically what I want to say is that it's important to use the right tool for the right job. And when I thought about how to frame it, or what's the rule of thumb here, I think that if you have a very well-defined task, that you can think about an algorithm that will solve this task in a deterministic manner, you don't need LLMs. Where LLMs really shine is where the task is not very well defined, and there is not an easy condition to be made in order to make the decisions. So for example, what needs our attention, right? There's no, there isn't an easy answer for that, right? You can't just have a condition and say, this VEP is blocked, or it has a low probability of surviving the code freeze. So this is where LLMs really, really shine, where you dump a lot of information from different angles, and it's a complex task that is not well defined. This is where an LLM can really help you understand what's going on. Another thing is that I was sure that if you use a better model, or higher effort, or higher reasoning, higher thinking, it will always perform better. And in reality, it just didn't work. So for example, let's say that I have all the information I need. After it was analyzed, now I have all of the realizations in place. And the only thing that I want to do is to send a Slack message, right? To summarize all of that and to send a Slack message. I think that the fast tier models will actually do a better job. The thing is that when it tries to think too much, it becomes too creative, it becomes too verbose, and it just brings more hallucinations into it. So sometimes when the job is just easy and straightforward, just give it to a fast tier model. Of course, it will also save you some money, but I think that the quality will also be higher. Another thing is that LLMs don't always listen, as I said. The way to deal with that is that we just had post-LLM corrections. So there are some obvious examples of places that you can just understand that the AI did a bad job. So for example, let's say that a VEP has a few implementation PRs. All of them got merged, right? Everything's great. It's already in. And although it's already in, it says it has a very low probability. I don't know why. Somebody, after it got merged, somebody came and said, this is great, thank you for your work, but in the next cycle, we have to solve this problem, right? Because it's, we can't go to beta. For alpha, this is great, thank you. But for beta, we have to deal with it. And the AI would just think, okay, the reviewer wasn't happy, so let's reduce the probability. So for obvious cases, post-LLM corrections really helped it to reach better conclusions. Another question is, how do you debug all of that? Let's say that something wrong happened. how do you even understand why, how it reached its conclusions, or why the mistake was made? And so what we came up with is the concept of snapshots. So after the deep reasoning is taking place, basically we tell the LLM, please try to make a huge list of, per VEP, just say what you had in mind, right? So what was the sentiment, the deadlines, whatever, everything we talked about, just try to give us a list, a huge list of what you had in your head when you were making these decisions. And the nice thing about that is that in every agent loop, it creates a new snapshot, and it compares it to the previous one. So that's useful for two things. First of all, for debugging, of course, because then you understand. So, for example, if the probability of a VEP changed drastically, you can understand that that something is going on, right? And maybe you should check it out. But it's also good for alerting, because even if it did a great job, you wanna have an alert for a VEP that its probability drastically changed, because that's a testament that it needs your attention, which is basically the goal of this whole thing. Another problem is the mocking problem. So how do you test it? How do you write automatic tests for it? And to be honest, I don't have a good answer for that still, because as I said, the agent is dealing with chaos, right? It's like 100 PRs, keeps changing every day. It's very hard to mock this situation into something that would be testable. So the only answer that I can give on this one is just try to eat your own dog food. Try to use, that's what I do. I try to use the agent every day on real data and try to really rely on it, so I would know if it makes mistakes and where are its weakest parts. And basically, this is how I try to continuously improve it. Okay, so let's talk about the future. Some of the stuff that are still, there are a lot of stuff missing, and this is still heavy work in progress, but I think that some of the stuff that I need to do next is, first of all, have to continuous feedback loops. So so the VEP owner, a lot of times just knows the situation, right? And if the agent does a mistake, the VEP owner can just say, or tell it so. I mean, no, the comment that you saw is just after the fact, after it got merged, it's fine. Don't worry about it. And the way I think to implement it is that it will write notes to itself for some kind of memory. And then maybe it will even dynamically improve during its runtime, but afterwards, it would need to be, we would need to look on it and understand if the notes actually make sense, and eventually bake them into the agent, into the prompts, into the code that's running in the agent to actually make it better next time. Another thing is to be able to ask the bot. So the process is sometimes hard to understand for newcomers. So I think it will be very valuable for newcomers to just ask it. So what do you think about my VEP? Do I need to do something different? Do I comply with the requirements? And I think that it will make it easier for people to participate. Another important thing is active governance. So there are a lot of requirements that we have that, for example, demand updating the design, updating the tracking issue, and stuff that are very bureaucratic. And the screen just disappeared. And it came back. Okay, the point here is that we want someone to nag you instead of us, so you will hate us less. If I'm going to a VEP owner and said, please update this, please update that, I don't want to do it. I don't want him to hate me for that. So if a bot does it for me, that's just a great benefit. I'm also working on a new agent, which is a review agent. It's not a substitute for tools like CodeRabbit or something like that, but it's mainly a complementary tool to do deep, heavy reviews that are very KubeVirt related. So that's another work in progress. And some final thoughts is that, first of all, one thought that I have is that as a community, as a repo, I don't think that we should, and this might be a bit controversial, but I don't think that we should actually have rules for agents, even not CloudMD or AgentMD in our repo. And the reason is that, first of all, we're talking about text here, right? It doesn't really matter if the text is based on documentation, which is also good for humans, or if we stick to a very specific convention, which is like the rules in the way that Cloud Code or something else reads them today, with the front matter and the metadata that it knows and stuff like that. What I think is that as a repository, and also, like, let's say that we have an AgentMD, right? Somebody comes along, wants to make a change, and they say, we don't want to change the content. We just want to change the phrasing and the style because it's more optimized for LLMs. And it shows us a study for that. How are we able to even assess that? What we know how to do is to write good documentation. And that's what I think that we should focus on. By the way, Anthropic have a really cool method of dealing with it. They have a documentation map, which is basically a table of contents, which is a small file with URLs for other documentation files that the agent can basically load into its context, and then it can dynamically go to the right documentation in order to load it whenever it needs to. This way, we can become completely agnostic in our repo. The other thing is that, as I said earlier, AI is not for everything. For some stuff, it really shines. And it does just an amazing job that is super hard to do with deterministic code. But it's not for everything. And I think that this experiment is actually nice. Trying to give it too much work to do and then reducing it and trying to understand where its limits are. But yeah, I mean, it's maybe a naive lesson, but it's an important one, I think. The other thing is that I really encourage everyone to build such things from scratch. It was a very fruitful experience. And by the way, I have another talk that I want to advertise here, which is basically a talk. It's a very long one, so it's but it's for how I did my local setup for Cloud Code. I have a lot of thoughts and realizations there, and I didn't want to make a very, very long talk. It's like over 2 hours about everything I think on this field. So if you want to and interested, you can watch it. And yeah, that was it. So thank you very much. Any questions? Yeah.
So basically, my question is that I like the point of the whole thing, but my setup is a little bit different. I'm basically running a small project, and I'm the only maintainer. So the load will be lower. But do you think that these things should be reused for a smaller scale project?
So yeah, the answer was if it could be reused for other repositories, basically, to reuse the same agent for other repositories. And I think that, so initially, what I thought is that I should have very, like KubeVirt-related specific context into my agent. But as time went by, I think this is a wrong approach. I think that basically you should have a good documentation in your repo. If you have a good documentation, you don't need a knowledge base. You don't need rules that are shared between your agents. Because the agents can just find the documentation and know what your policies are. So the answer is yes. I think that it could be reused. I think that the direction that I want to take this stuff in is just to remove specific knowledge from them entirely. And just say, instead, go to the repo and try to understand what's going on, If you have this table of contents map for documentation, I think that's very helpful. And then you can have a single agentmd file for your agent that will just say, look at this file. This file will have everything you need. And then you're done. So yes, I think that this is the right direction. Any other questions? Yep. So the question is, if I heard you correctly, if the rules inside the documentation needs to be.
The documentation should be more like written from a functional perspective or strictly technical.
Okay, so is the documentation, should it focus on functional documentation or technical one? Right. So, or what's better for the agent to have? And I think like. As communities, right, we know how to write good documentation, right? What I really think is just write good documentation. Think that there's a human out there that reads it. And another important idea that I want to give you is that, like, everything you write, you should not think about the LLMs of today, but the LLMs of a year from now, right? In a year from now, they might be a lot more sophisticated. Don't try to fine-tune it or optimize it for LLMs. That's what I want to get across. Just write good documentation. You know how to do that, right? We have an expertise on that. Let's focus on that and not try to overfit to what we have today and the conventions that we have today and the levels of the LLMs that we have today. Any other questions? Yep. How much does it cost to run it? That's a good question. The answer is, I don't really know. I'm not the one that's paying, but that's a good question. Maybe I will even check it out. It's interesting. Right. I would have to get back to you on that, but it is interesting. Yeah, it runs every few hours basically, and it does, I don't know, maybe 10 to 20 LLM calls total every few hours. So I imagine it's not a huge cost, right? It's not running continuously. We think to make it an event-based. Maybe it would become more expensive then, but yeah, it's a good question. All right. Last question, anyone? Okay, thank you very much. Have a great rest of the day.